Okay, so we left off talking about the Python version of the adsorption code. Basically, this file encapsulates the utility functions, everything you need except the main loop. The solution 9 file is analogous to the MATLAB code with the same name, and so is converge.me. I just kind of copied over into Python, and I added a lot of comments compared to the MATLAB code, I believe. So there's a little bit more description of what's going on, at least at the beginning. Everything works the same way, except there's this dot notation for the object-oriented programming, and the plotting commands are a little bit different. Also, you have to explain what pieces of code you're importing at the beginning of each file if you're running that as a main file. So I use these utility libraries NumPy and SciPy, for numerics, and then matplotlib for plotting. This comes with matplotlib, and then I'm importing my own code here, just some utilities, and then I can call those things without addressing them with this adsorption dot beforehand. So again, this works pretty much the same way. It's slightly rearranged, perhaps, that I don't quite know how this works. There's a lot of code. There's a couple of objects here that are meant to be run as iterators, and they'll run through a parametric study and show plots for each step, for each of the given inputs. So I use this notation, create a chiller as an object, and then this will run like a parametric study and give me the output of the optimized chiller from that. So I should check into this and see exactly how it works. But basically, this is the same kind of setup as in the MATLAB code to do this kind of optimization. And when I say optimization, I mean optimization of cycle step times, the dwell time for the desorption and adsorption steps. Coming out of here is some kind of variable, and then we're collecting the performance metrics given that optimum and recording them versus whatever independent variables being changed here. So we have to see what a something is. It's a converge.me object. So this converge.me object, and using Python, this init is like the object creation constructor. So it's setting up the problem, just the basic definitions, and then these interpolation functions are being created up in the head there. It's also creating plots if we want it to, not necessary to running the calculations. And then this would be running through the entire parametric study in this function using these loops here, and then these are doing array matrix calculations, and then some calculations. This looks like it's determining the temperature based on this array here. Compression. So again, we see here, this is the heart of the problem. It looks a lot like the MATLAB code, except a slightly different notation. We're looking for this max So this is the notation using NumPy arrays. This is the array. This is the cooling capacity as a function of which index into the array of high and low adsorbed mass ratios. So that's treated as the input into this array, masking off non-physical inputs, finding the index that maximizes that array, and then asking for that as a pair, like low comma high index. And then we're using this index to get from these output arrays that were created during this calculation loop. So we're building up how long is the cycle based on the desorption expansion, I guess I'm calling it here, instead of decompression, adsorption, and then the compression. So we're adding up all those times to get the total. We got the COP already calculated, the cooling capacity, and of course those high and low desorbed or adsorbed mass fractions. And then I had an option here. This is where code gets messy and it's not looking so great. Because this is a discrete optimization over this set of points that was already generated here, it might not be very smooth in a parametric study. So there was this optional refine that. This is not very good style for numerics, but it was just what I came up with while revising the code to make it a little smoother. And then here's some plotting, optional plotting. So that's the basic thing that comes out of this converge me. It sets things up, and then it solves, it optimizes the low and high desorbed mass fractions and the corresponding the dwell times for each of the steps in the process. And those are the outputs as a tuple in Python. And then this parametric study 1 is using that object it's in each step of the parametric study, it's creating that converge me object, getting those optimal outputs, and then building this array for all the performance metrics that we can plot and look at. So this first parametric study looks like it was looking at exhaust range, and then I've set it up. I can just copy paste, change the variables I want to study. So here, this second parametric study is looking at the heat exchange coefficient in the desorber step. So now this model now has separate desorber and adsorber, I believe. So we have, these are the, need a little bit better documentation. It's maybe up here. So I need to revisit the documentation. Those U are heat exchange overall coefficient. Excuse me.